big data learners, Python learners, and data leaders. Welcome to Insight Builder channel. Own your big data cluster in cloud. The why and how. Before we even enter into big data and owning a big data cluster, we need to understand why you need a big data. See, a file that becomes really bigger than your random access memory in your server or in your laptop, then the file crashes the program that is accessing that file. That is why you have to resort for big data clusters. In case of big data cluster, the big file actually is split into multiple smaller files and then it is spread across various nodes. You might be wondering now, how does the program or the particular script that is processing the big data files, that is the split files, it is done by the help of big data softwares like Hadoop, Spark, and especially the catalog, the big data catalog that is stored inside the regular database like Postgresql. If you are new to this particular video or this particular series, I would suggest that take a look at my playlists that is hosted in the YouTube channel under this Mastering the Python Ecosystem. You will see that in this playlist there is a video on PySpark. I introduced PySpark and how to do ETL for millions of lines. These two videos will actually give you a very good understanding of the challenges that you face with respect to big data. Without further ado, let us proceed. Now we know what is big data and why big data is required. Now the question is why you need to build your own big data cluster, BYOB. First and foremost, there are 6 points that I wanted to highlight. Once you build your own big data cluster, you can clearly understand the ecosystem around the big data softwares. Ecosystem, every application or every challenge that is faced in this world is solved by many people, and all those people create their own softwares and they actually attach it to an ecosystem, like in this case the big data ecosystem. You will get an idea, okay, all these things are there. So once you build it, once you get a hands-on, you will get an idea, okay, these are the softwares that are working. Second, you will have the skill set to build your own environment and practice. This is a quintessential requirement of any engineer or a developer who is looking forward to enter into big data. You might be an awesome software engineer, programmer who is already developing lots of applications, but these are all working inside the RAM, inside a single RAM that is on a server or a laptop. But when you are going to span it across multiple servers and if you are going to create a cluster and nodes, the programming is going to be different. You don't need to understand how the cluster programming is done. That is already taken care by various softwares like Scala and Spark. That is taken care. At least you will need to understand how to implement those software in your environment. For that, you will need to get an hands-on. Okay. The third important point, how each application connect and talk. In this world right now, there are so many different tools, so many different devices and applications running, and making them talk is one of the major challenge, and that too reliably. The key point is reliably it should talk in production. If there is any challenge when it comes in production, the recovery of the challenge, troubleshooting and recovery has to be also really fast. And how are you be able to do that if you are going to try out all these things in production environment? It's not going to be feasible. So you need to have a local environment where you can test out your ideas, where you can actually tweak and break things also. The most important thing is that you need to be able to break the things easily and refit it. So it's kind of a workbench for you. And finally, there are two more important points that I wanted to highlight here. You can touch and move the raw data. Okay, what I mean by touch and move the raw data. Let me go back to a previous slide. I told that the servers, the nodes in the big data cluster actually holds the divided files, correct? What if you want to see the divided files? What if you want to move around the files that has been already divided? That level of control you will get once you understand and build your own big data warehouse. And finally, see through the technology abstraction. The main reason why I am making this entire series and putting the big data data server and why it has to be built by yourself is this: the technology, as I was telling, is becoming really complex, and in the future we may not even know what is actually running the big data, what is actually running the nodes in the big data, which has to be changed at a very urgent rate. We have to understand how the big data system works. It's basically a file system, like how your operating system like Windows and Linux works. Only thing is it is distributed. That actually should excite us, correct? But we are afraid of it. Most of us, whomever we discuss, big data is considered as a very different area that only selected people go. Actually, it's not the case. Anybody can understand big data. And my primary goal of this series is to make it accessible, very accessible. And how am I going to do it? The main point that I am going to target is to get yourself a big data cluster. And I am going to show you in series couple of 4 or 5 videos that how you can install your own big data cluster and start running the scripts inside that cluster. Yes, you are going to build your own big data cluster and you are going to run it. You are not going to use any of the cloud services that has been provided, but you are going to build it by yourself. If you are excited about this, take a look at the rest of the videos that is going to come in this series of playlists. But if you are still not convinced, then still take a look at the videos. You might actually find some inspiration or some clue as to how to solve some of your problems. With that said, the steps we are going to use to build the cloud big data is to, first of all, you need to get a cloud service access. So sign up for any of the cloud service access like Azure, GCP or AWS. I'll be using AWS. You can use any of the cloud services because the compute layer is what we are going to use. The compute layer, the virtual machines or the instances, the virtual machine instances the cloud service providers give, that is what we are going to use. Second, we need to understand what is the compute required. We need minimum of 8 GB RAM with 22 GB of hard disk space and 2 vCPUs. This is the bare minimum requirement. I am not asking that you need to have 32 GB of RAM and 8 CPUs. No. Start with bare minimum. You are going to learn. Okay, start with bare minimum. Third, get Ubuntu Linux on the compute. This is one of the key aspects that I wanted to share. That you are going to use basic Linux, and then you are going to load the file system on the basic Linux only. There is no separate operating system. So if you are thinking that, okay, big data will have a separate operating system, no, that is not how it works. And we are going to set passwordless login for that particular operating system. Fourth, we are going to set up Python. In order to run PySpark and Jupyter Lab, we are going to set up Python. We will be downloading the installers like Hadoop, Spark, Postgresql, Docker, etc. And we will be configuring that in the final step, the 6th step. This is how the overall process is going to proceed. The ecosystem that which I was talking about is, these are the major tools that are part of the ecosystem that we will be using for building our own big data cluster. First and foremost, Hadoop is the file system. Spark is the query engine that works on the Hadoop file system. And Hive is also one of the other query system that was used, even it is still used today also. We will be installing it, but we will resort to using Spark because of its lazy programming feature. For programming and scripting, we will be using Python and PyScript. We will be installing this entire big data cluster on Ubuntu Linux support and Postgresql catalog support. You might be wondering, okay, what is Postgresql database doing inside the big data cluster? I told you that in this particular slide, the files will be split and it will be spread across multiple clusters or multiple nodes inside the cluster. How will the compute service or the program, the script that you write, knows where the files are, where the data is? The PostgreSQL database acts as a catalog and tells the script and the like scripts like that is written in Spark, that is written in Hive query, that where the files are. That is called as a data catalog, and PostgreSQL database helps in that. Finally, we have Hive user experience, Hadoop user experience, sorry, that is a different, altogether a different application that we will also be trying to load. And then Presto, it is a federated querying engine that is better than Hive and Spark, but it has a different purpose altogether. These are the major tools that we need to be aware of, not only using but also to install. Once you understand how to do all these things, okay, this is what you can finally get your hands on. It's a multi-purpose, multi-project environment. Okay, whether you are going to use Kafka or EC2 instances from any of the cloud services, or whether you are going to use Docker and Airflow to make some kind of ETL transformation and load it on, integrated with data warehouses like Snowflake or Redshift, you can actually do those things. And you can actually work at the configuration level because it's your big data cluster, and if it breaks, you know that how to build it again. And the major challenge, the major point again I am re-insisting is that all these tools that is surrounding the big data ecosystem, the ETL process or the ELT process, they actually give the names, new names. But the point is that you are going to extract the data from somewhere, transform it and load it, right? You can actually do it in any format you want. So there are so many concepts that comes at the operation and application level. But we are at the very, very basic, at the very bottom layer of where the actual files, the raw files are getting moved. So you actually can work with basic Linux commands also to move the data. But we use Spark and we use Hive and we use Hadoop for a reason. As I was telling, that the files are very big and you cannot use a single device's RAM or a single server's RAM to process that. That is why we are actually using Hadoop file system or the HDFS. I will be explaining more as I start going into the next series of videos. And this is the main point of this particular video, to introduce what is expected and why we are going to build your own big data cluster and how to build it, where to start. So this video is introducing that. Stay tuned for the next series of videos where I will give the overview of how to first of all get the hands on your compute and then take to a step forward and install and configure the compute environment. So both of these videos I will be uploading will be there in this series of playlists. Take a look at that. And the main point that I wanted to highlight is that this series or all the series in my playlist, all the videos in my playlist, if you take a look, is geared towards helping people to practice. So take a look at the other, especially the Learn Data Engineer and Problem Solving playlist. That gives a huge amount of information regarding the ecosystem surrounding the big data challenges, ranging from Python to Python's various Linux, Python, Docker. All these are discussed in this playlist. So coming to the final point, do practice with all these resources available out there. All you need to do is take your time out and work on these tools and technologies so that you by yourself can have an immense amount of knowledge and also share it with others when there is a challenge and troubleshoot your own problems very easily. So with this, guys, I would like to end this video. Do leave a like for the video so that I will know that my content is useful, and share it with others, and subscribe to my channel so that the future videos will, when I upload the future videos, you will get the update on your YouTube dashboard. With this, guys, have a great time, and 4 words as usual: practice, 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 practice. See you guys.